nix-p2p is a decentralized Nix binary cache. It runs as a local host daemon that speaks the standard binary cache HTTP API, but it fetches store paths from peers instead of only a central CDN. One mechanism serves three uses: trustless offload of cache.nixos.org, a LAN cache with no server, and a pool that shares a team's own builds. The core principle is a trust boundary. The daemon and every peer sit outside the trusted computing base. Nix store paths are content-addressed, so an unmodified Nix client re-verifies the signature and the hash itself. A hostile or busy peer costs a bounded, self-healing retry, never a bad store path. That safety is what lets sharing be useful out of the box, with zero config. Inside, three seams keep it clean. Serving hides behind two source interfaces. All peer-to-peer sits behind one peer fabric seam, so the serving core holds zero networking types. lib2p is the proven trunk, Cadelia discovery, identify, and LAN or mainline bootstrap. Peers transfer raw NARs over a bow-authenticated protocol. A Nix build flows through the daemon to peers and falls back to the CDN on a miss. What a node gives is governed by one setting, its sharing profile. Upstream only, the default, shares nothing. Consume only fetches without serving. LAN share serves your local network. Public share opts into the wider swarm. Router just helps peers find each other. A profile that contradicts a flag fails closed at startup. Bootstrapping is MDNS on the LAN or an opt-in mainline rendezvous across the internet. Discovery is Cadelia. A provider query answers who holds a given hash, adopted from a mainnet-proven library rather than hand-rolled. MDNS and mainline only bootstrap peer addresses content routing stays Cadelia exclusive. Transfers are Blake 3 and bow verified, streamed leaf by leaf. And every budget and admission decision is computed in integers or exact rationals, no floats, an owner rule with amplification charged at spawn. Storage is deliberately thin. The Nix store itself is the content-addressed backing. A node keeps no second copy, regenerating a path's raw NAR on demand. One trap to remember: uncompressed NAR bytes and compressed transport bytes are different units. Never compare them directly. The narinfo cache evicts by entry count, not a hard byte cap, and durable state is just node identity and an anti-rollback sequence floor. Peer fabric separates discovery from transport. lib2p is the trunk. Eero and BitTorrent were explored, then superseded, kept only as optional transport backends. The honest first product is LAN first and org first. Machines on the same nix-p2p's pin share almost their whole closure, while overlap across different revisions is structurally near zero. NAT traversal and relays for residential peers are still unfinished work. Security rests on that same content-addressed boundary. Even a hostile peer cannot inject a bad path. A LAN share node is walled off from the public swarm by a dial veto, per connection serve provenance, and a distinct DHT scope. The shipped serve path carries do-s controls, a per-peer amplification cap, an upload rate shaper, and a serve concurrency bound. Signing stays upstream, with pool signing planned for non-cache paths. A few deeper pieces. The operator contract is a frozen, content-hashed artifact with typed budget fields, so what a node promises is pinned in bytes. The NAR serve streams with bounded memory and a whole operation timeout, defeating a slow Loris peer. And the privacy direction, trust-isolated pools, blinded rendezvous, self-certifying provider records, charts where the project is heading. Finally, an honest roadmap. The trust tier has not been run against the live cache in a real deployment. On bytes, peers are measured to supplement the CDN at near parity. They do not beat it. The speed question stays deliberately open. Operator contract hardening and biting streaming oracles are in progress. Whole store offering and pool-signed metadata are directions, not yet shipped.